Our eye in the sky has been the James Webb Telescope, which has brought the cosmos closer to us by peering into the depths of space. Through its lens, science has been extended and the impossible has been deciphered. During one of its developments, the James Webb Telescope uncovered a picture of Proxima B, our nearest exoplanet neighbor, caught exhaustively. However, an unexpected event occurred. What might that be? And what mysteries still need to be resolved by the James Webb Telescope? Follow along as we decipher the meaning of this image and the sudden silence of the world's largest space observatory. The purpose of the James Webb Space Telescope, JWST, was to revolutionize infrared astronomy. It surpasses the capabilities of its predecessor, the Hubble Space Telescope, by enabling the observation of previously inaccessible objects due to their age, distance, or faintness. It is equipped with cutting-edge instruments with high resolution and high sensitivity. Numerous research avenues in astronomy and cosmology are made possible by this groundbreaking capability. An amazing discovery has been made by astronomers. 6 massive galaxies from the very beginning of the universe have been identified. If they are true, these enormous objects could completely alter our understanding of how galaxies form and develop. The data were gathered by the powerful infrared sensing instruments of the James Webb Space Telescope, and the results were published in the prestigious journal Nature. This information gives us a glimpse of the universe's appearance 13.5 billion years ago, when it was only 3% of its current age. The fact that these hypothetical galaxies, which may have existed only 500 to 700 million years after the Big Bang, had already reached a maturity level comparable to that of our own 13-billion-year-old Milky Way galaxy is truly mind-boggling. It is estimated that the stars in these objects are several billion times more massive than our Sun. The study suggests that the mass of the stars in one of these galaxies could be as high as 100 billion times that of our Sun. To put this into perspective, the mass of the stars in our Milky Way galaxy is roughly equivalent to 60 billion suns. This discovery challenges our preconceived notions about how galaxies come into existence, provides a tantalizing glimpse into the early stages of galactic evolution, and serves as a stark reminder of the immense scale and complexity of the universe. This study has profound repercussions, and you will be surprised by what transpired following the James Webb Telescope discovery. Co-author of the study and University of Colorado Boulder astrophysicist Erica Nelson expressed surprise at the rapid appearance of galaxies with as many stars as the Milky Way. She talked about how amazing these findings are. In the Centaurus B star system, she also found an exoplanet that was 11 times larger than Jupiter, the largest planet in our solar system. The Centaurus B star system is known as a young binary system because it is made up of 2 stars that revolve around the same mass. This particular star system is approximately 3,125 light-years away from our planet, which is a significant distance. One of the largest planets ever discovered, Centaurus B revolves around 2 stars that are significantly heavier than our Sun and have a combined mass 6 to 10 times greater than our own. As a result, the Centaurus system is the largest known to contain a planet. Additionally, Centaurus B is acknowledged as the planet-hosting star system with the highest temperature. In cosmic terms, the 2 Centaurus B stars, also known as Centaurus A and Centaurus B, are only about 15 million years old. Our Sun, a G-type main sequence star, on the other hand, is much more mature because it has been shining for more than 4.5 billion years. The Centaurus stars are still young, but they have already gone through a number of stages of stellar evolution, which have shaped their characteristics and influenced how they will develop in the future. In the initial stages of the universe's development, the researchers had hoped to find tiny, young galaxies. The study's principal investigator, Alabra, from Swinburne University of Technology in Australia, referred to these galaxies as monsters that appear to have matured rapidly. Scientists are intrigued and eager to learn more about this phenomenon due to the unsolved mystery of how these galaxies reached such a level of maturity at such a rapid rate. In addition, they found something even more intriguing: Proxima Centauri close to the Centaurus B star. Proxima Centauri is a red dwarf star that is less than 4 light-years from Earth. It is famous for its numerous and powerful radiation flares. Any planet in orbit around the star could be significantly affected by these powerful bursts of stellar energy. The atmosphere and surface of Proxima Centauri may be adversely affected by the radiation that is released during these flares, possibly removing the gaseous barrier that sustains life. Any potential life forms on the planet could also be seriously harmed by the intense radiation from Proxima Centauri flares. Complex life could struggle to evolve on Proxima Centauri B if organisms were subjected to harmful radiation levels, which would make it difficult for them to survive and reproduce. Scientists and astrobiologists alike are intrigued and excited by the possibility of a life-supporting environment on Proxima Centauri B despite these obstacles. Scientists have discovered that Proxima Centauri B can maintain vast areas of liquid water on its surface in a variety of scenarios by utilizing sophisticated computer models similar to those used to study climate change on Earth. The possibility of the exoplanet being able to support a variety of life forms is significantly increased by this exciting development. Even though it is close, scientists still don't know much about the planet that is next to Proxima Centauri. It is known that the planet orbits its parent star once every 11 days and has a mass at least 1.3 times that of Earth. Researchers eager to learn more about this fascinating celestial body face a unique obstacle as a result of the lack of information. This brings us to a crucial question. Is life possible on Proxima Centauri B? The exoplanet Proxima Centauri B is in the habitable zone of its parent star and orbits at a distance that allows it to receive enough starlight to keep its surface temperature above that of water. Because water is so important for supporting life, this crucial location in the habitable zone suggests that the planet's surface may contain liquid water. However, it is interesting to note that Proxima Centauri B's planet may have become tidally locked as a result of the intense gravitational forces at work because of its close orbit to its star. A phenomenon similar to the Moon's relationship with Earth, where only one side is visible from our vantage point, is referred to as tidal locking. Tidal locking occurs when one side of the planet always faces its star, while the other side remains in perpetual darkness. The atmosphere of Proxima Centauri B could take one of two possible forms. One possibility is that the planet's water condensed, releasing hydrogen into space, leaving only oxygen or carbon dioxide in the atmosphere at the beginning of the planet's history. On the other hand, water escape would have been restricted if Proxima Centauri B had a primordial hydrogen atmosphere or had formed further from its star. This gives rise to the possibility that Proxima Centauri B may have kept its water throughout its early history. Oxygen and carbon dioxide are likely to be oxygen-bearing gases in the planet's atmosphere if it exists. These gases could result in the formation of auroras that could be seen from Earth and give the impression that the planet has a magnetic field when they are combined with the star's magnetic activity. But there's more. The atmospheric properties of Proxima Centauri B have been simulated with the help of climate models, such as the general circulation models that are used to simulate the climate on Earth. The planet's tidal lock, the presence of water and carbon dioxide, and a variety of other variables are all taken into account by these models. The circumstances on Proxima Centauri B could lead to a number of different scenarios. Could be a planet that is entirely or partially covered in ice. Alternately, it could be a massive planet with numerous oceans or smaller water bodies. Additionally, there is the possibility of regions with no land at all. Even unique features like eyeballs or lobster-shaped areas with liquid water that looks like claws emerging from the equator are suggested by some models. In addition, researchers speculate that a subsurface ocean lies beneath a slushy, thin ice cover that may vary in thickness depending on the location. Scientists have been able to investigate the possible conditions on Proxima Centauri B and consider the numerous possibilities for this distant exoplanet by utilizing climate models. So, is Proxima Centauri B habitable then? Due to the strong UV and X-ray rays that its star, Proxima Centauri, emits, the habitability of Proxima Centauri B is difficult. When compared to Earth, this planet experiences significantly higher levels of radiation, particularly X-rays. It may have even received more in the past, resulting in cumulative XUV radiation that is 7 to 16 times greater than Earth's. Hydrogen can absorb this radiation and become trapped, eventually reaching a point where it can escape the planet's gravitational pull, causing the atmosphere to evaporate. Additionally, the radiation has the ability to separate water into oxygen and hydrogen, with the hydrogen heated in the planet's outer atmosphere until it escapes. Other elements, such as nitrogen and oxygen, may also be lost as a result of this process. Even though nitrogen and carbon dioxide can escape on their own, their content on a planet similar to Earth is unlikely to significantly decrease.